Hello, my name is James Creswell. Since 2007, I have been lucky enough to work in both polar regions as an expedition guide. These experiences have had a profound effect on me, and I have become a witness to their climatic change. I have made this video to share my observations, and I hope it will influence and inform those who are still undecided on the issue. The Antarctic Peninsula is changing rapidly. It is warming at 4 times the global average. Some places have seen an almost 3-degree rise in the last 50 years, and 87% of its glaciers are in retreat. The most dramatic change is the loss of floating glaciers that fringe its coasts. These are called ice shelves. 6 of the 10 have collapsed in recent years. The diagram colours these green and shows the date of their collapse. For example, the Larsen B ice shelf, that was the size of Rhode Island, collapsed completely in 2002, in the space of just a few weeks. This was followed by a partial collapse of the Wilkins ice shelf in 2008, as the following BBC report details.
A chunk of ice the size of the Isle of Man has started to break away from Antarctica in what scientists say is further evidence of a warming climate. The massive Wilkins ice shelf has been stable for most of the last century but is now at risk of collapse. Palab Ghosh reports.
The latest crack in the Antarctic. This stretches for 25 miles. Just one sliver of ice is holding the Wilkins ice shelf onto the mainland, and very soon it could become the largest chunk to drift off the Antarctic Peninsula. The blue tinge on the ice shows that the fracture is fresh. It happened just a few weeks ago, and it's rising temperatures in the region that's thought to be to blame.
These collapses are not isolated events. The changes to the ice continue to occur. And in February 2010, an iceberg the size of Luxembourg broke off an East Antarctic ice sheet. The retreating glaciers have been observed via satellites. However, I have also witnessed changes with my own eyes. For example, in the penguin colonies we visit, the numbers of adelies have been reducing as they are replaced by subantarctic gentoos. The Arctic is also changing rapidly. The Jakobshavn Glacier is the main drainage outlet of the Greenland ice sheet. It has retreated 40 kilometres since 1850, and a staggering 20 kilometres since 2000 alone. But the most dramatic change in the Arctic is the disappearance of sea ice. In 2007, the northern route through the Northwest Passage became completely ice-free. I myself went through the Northwest Passage twice in 2008 and saw virtually no sea ice. This animation shows the September minimum amount of sea ice. It is clear to see how it is reduced over the years. The present amount of sea ice is about half of what it was in the 1980s. It is not just the total amount of ice that is getting less, the ice is also getting thinner too. The white ice in this graphic is ice older than 5 years old. Here you can see it rotating in the Beaufort Gyre and draining away down the east coast of Greenland. By 2007, virtually all the ice older than 5 years had gone. Some scientists predict Arctic sea ice may disappear completely during the summers within just 30 years. This will have a major effect on wildlife, such as polar bears, walrus and seals, who need it to breed and feed. The red colour on the map shows the extent of disappearing polar bear habitat. The disappearance of the sea ice will also open the Arctic to oil production and shipping. The Northwest Passage is predicted to become one of the busiest shipping lanes in the world, and the Arctic basin is thought to contain huge oil reserves that can be exploited once the ice has gone. These witnessed changes to the polar regions are due to a warming climate. The planet has warmed 0.75 degrees in the last 150 years. During this time, sea levels have also risen, and also the amount of snow and ice cover in the northern hemisphere has decreased. As a geologist, I know the planet has warmed and cooled many times during its vast history. The last 1 million years has seen a series of ice ages and interglacials. These climate changes were due to variations in the Earth's orbit called Milankovitch cycles. Sunspots are another solar phenomenon that have also been shown to have a small effect on climate. However, the changing orbits are not the full story. From ice cores drilled into the Antarctic ice, scientists have been able to identify the composition of the atmosphere during the last ice ages and interglacials. This data shows that when it was warmer, there was more CO2 in the atmosphere, and when it was cooler, there was less. It is thought that the Milankovitch cycles caused the initial changes, but this was then amplified by the planet naturally producing more or less CO2 due to feedback mechanisms. Why would carbon dioxide affect the climate? Well, it is a greenhouse gas. When solar radiation arrives at the Earth, some is naturally reflected back to space, only to be re-reflected by the greenhouse gases in the atmosphere back to Earth. This is a natural phenomenon. Other greenhouse gases include methane and nitrous oxide. This graph shows how the amount of carbon dioxide in the atmosphere has been relatively stable for the last 10,000 years. However, it suddenly shot up 150 years ago at the start of the Industrial Revolution, and its level is now 390 parts per million, the highest it has been for 800,000 years. This graph shows that the amount of methane has also shot up. Similarly, we can see how the amount of nitrous oxide in the atmosphere has shot up as well. So, is human activity the cause of the observed warming? Well, to answer this question, scientists have devised a series of computer models that include all the natural solar cycles and the greenhouse gases in the atmosphere. In 2007, the Intergovernmental Panel on Climate Change produced these graphs. If you first look at the bottom left-hand corner, you will see that when they ran their model removing the effects of mankind, they obtained the blue line. When they reran their models including mankind, they got the pink line. The black line is actually what happened, and as you will see, there is an exact match. This led them to conclude that the warming observed in the last 150 years is due to the effects of mankind with a 95% certainty, and the same can be seen on all the continents and also on the land and in the oceans. This is not all. The IPCC have run their models to predict future climate change. The models suggest that emitting CO2 at predicted 2015 levels for the next 100 years will lead to a 2.8 degree warming. But if we continue to emit at our current rate of increase, the temperature could rise by as much as 6.4 degrees. What would these temperature rises mean? Well, no one knows for certain because this is speculation. But a 2.8 degree rise is likely to tip the Greenland ice sheet into irreversible melt, which will ultimately lead to a 7-meter rise in sea level. This map shows the effects that this would have on the coast of the USA. A 6-degree warming would be far worse. And if this was to occur, it is very unlikely that the planet will be able to support current populations. Considering that global CO2 levels have increased 40% since the 1990s, this is becoming an increasingly likely possibility. These two excellent books by Mark Lynas and James Lovelock explore these topics in further detail. Even though climate change is a reality, it is not all doom and gloom, and we can choose how warm we want to let the planet get. Most of the technologies already exist to avoid its worst effects. For example, covering an area of Sahara, the same size as the Big Red Square, in concentrated solar power stations, could provide enough electricity for the entire planet. And it has been envisaged that this could be the basis for a whole new electric grid for Europe. So if you want to do something to help us all avoid dangerous man-made climate change, it is not easy, but here are some suggestions of what you could do. Firstly, you could write to your political representatives, making it clear that you want climate change mitigation to be top of the agenda. Only use the car for vital journeys. Buy an electric car when they become affordable. Reduce the amount of flights you take. You can switch your power supplier from a fossil fuel tariff to a renewable tariff. Insulate and ventilate. Also eat locally produced food. Stop drinking bottled water. Eat less meat. And finally, make others aware. And please visit climatechangewitness.org for more information and to leave some feedback. Thank you.